the measurement piece is key. Having transparency and understanding always helps. What gets measured gets fixed. It's very simple. But the step that comes after that, I think we're currently jumping the gun on that because we haven't measured a lot of stuff.
Hello, and welcome to Environment Variables, brought to you by the Green Software Foundation. In each episode, we discuss the latest news and events surrounding green software. On our show, you can expect candid conversations with top experts in their field who have a passion for how to reduce the greenhouse gas emissions of software. I'm your host, Chris Adams. Hello, and welcome to another edition of Environment Variables, where we bring you the latest news and updates from the world of sustainable software development. I'm your host, Chris Adams. We're doing something a bit different today, because a friend and frequent guest of the pod, Max Schulze, is actually turning up to Berlin in person where I'm recording today. So I figured it'd be nice to catch up with Max, see what he's up to, and just catch up really. So Max, we've been on this podcast a few times together, but not everyone has listened to every single word we've ever shared. So maybe if I give you some space to introduce yourself, I'll do it myself and then we'll move from there, okay?
Sounds good.
All right then, Max. So what brings you to this? Can you introduce yourself today?
Yeah, I think the first question, why am I in Berlin? I think there's a lot of going on in Europe in terms of policies around tech. In the EU, there's the Cloud and AI Development Act. There's a lot of questions now about data centers. And I think you and I can both be very grateful for the invention of AI because everything we ever talked about, now everybody's talking about 10x, which is quite nice. Everybody's thinking about it now. Yeah. My general introduction, my name is Max. For everybody who doesn't know me, I'm the founder of the SDIA, the Sustainable Digital Infrastructure Alliance. And in the past, we've done a lot of research on software, on data centers, on energy use, on efficiency, on philosophical questions around sustainability. I think the outcome that we generated that was probably the most well-known is the Energy Efficiency Directive, which is forcing data centers in Europe to be more transparent now. Unfortunately, the data will not be public, which is a loss, but at least a lot of digital infrastructure now needs to be more transparent on their resource use. And the other thing that I think we got quite well known for is our explanation model, the way we think about the connection between infrastructure, digital resources, which is a term that we came up with, and how that all interrelates to software. Because there's this conception still that we are building data centers for the sake of data centers, but we are, of course, building them in response to software, and software needs resources, and these resources need to be made somewhere.
I see.
And that's I think what we're well known for.
Okay, there's two things I might jump into a little bit earlier and a little bit later on in a bit more detail. Mm-hmm. So if you're new to this podcast, my name is Chris Adams. I am the policy chair in the Green Software Foundation's policy working group. And I'm also the director of technology and policy in the confusingly but similarly named Green Web Foundation. All right. Max, you spoke about two things that if I can, I'd like to dive into in a little bit more detail. So first of all, you spoke about this law called the Energy Efficiency Directive, which, as I understand it, essentially is intended to compel every data center above a certain size to start recording information. And in many ways, it's like sustainability adjacent information, with the idea being that it should be published eventually. Could we just talk a little bit about that first and maybe some of your role there, and then we'll talk a little bit about the digital resourcing that you mentioned.
Yeah, I think on the Energy Efficiency Directive, even one step up, Europe has this ambition to conserve resources at any time and point. Now, critical raw materials are also in that. Energy efficiency, normally actually this law sets thresholds. Like it is supposed to say a building shall not consume more power than X. And with data centers, what they realize, actually, we can't set those thresholds because we don't know reliably how many resources are being consumed. So we can't say this should be the limit. Therefore, the first step was to say, well, first of all, everybody needs to report into a register. And what's interesting about that, it's not just the number that in data center land everybody likes to talk about, which is PUE, power usage effectiveness. And so how much overhead do I generate with cooling and other things on top of the IT, but also that it for the first time has water in there. It has IT utilization rates in there. It even has, which I think is very funny, the amount of traffic that goes in and out of a data center, which is a bit like, I don't know what we're trying to measure with this, but sometimes you got to leave the funny things in there to humor everybody. And it goes really far in terms of metrics on really trying to see what resources go in a data center, how efficiently are they being used, and to a certain degree also what comes out of it. maybe traffic. Yeah.
I see. Okay. All right. So it's basically essentially trying to bring the data center industry in line with some of other sectors where they already have this notion of, okay, we know they should be this efficient. And like we've had a lack of information in the data center industry, which made it difficult to do that.
Yeah.
Now, I'm speaking to you in Berlin, and I don't normally sound like I'm in Berlin, but I am in Berlin, and you definitely sound like you're from Germany, even though you're not necessarily living in Germany. Yeah. Maybe it might be worth just briefly touching on how this law kind of manifests in various countries, because I know that like this might be a bit inside baseball, but I've learned from you that Germany was one of the countries that was really pushing quite hard for this energy efficiency law in the first place. And they were one of the first countries to actually kind of write into their own national law. Maybe we could touch a little bit on that before we start talking about the world of digital resources and things like that.
Yeah, I think even funnier, and then you always know in the Europe that a certain country is really interested in something. They actually implemented it before the directive even was finalized. So for everybody who doesn't know European policies, the EU makes directives, and then every country actually has to, it's called transpose it into national law. So just because the EU, it's a very confusing thing, makes something doesn't mean it's law. It just means that the countries should now implement it, but they don't have to, and they can still change it. So what Germany, for example, did in the directive is not mandatory to have heat recovery. So we're using the waste heat that comes out of the data center, but also the EU did not set really thresholds. But of course, Germany was like, no, we have to be harsher than this. So they actually said for data centers above a certain size that needs to be powered by renewable energy, you need to have heat recovery. It's mandatory for a certain size. And of course, the industry is not pleased. So I think we will see a revision of this. But it was a very ambitious, very strong, let's manage how they build these things.
Ah, I see. Okay. There is I think, is there a German phrase? Trust is nice, control is better, or something like that. Yeah. Okay. All right. So if I'm just going to put my program ahead on. So when I think about a directive, it's a little bit like maybe an abstract class. All right. And then if I'm Germany, I'm making a kind of concrete, I've implemented that class in my German law, basically.
Interfaces and implementation.
Okay. All right. You explained it into nerd for me. That makes a bit more sense. Thank you for that. All right. So that's the ED. And you essentially were there to use another German phrase, watch the sausage get made. So you've seen how that's turned up. And now we have a law in Germany where essentially you've got data centers regulated in a meaningful way for the first time, for example. And we're dealing with all the kind of fallout from all that, for example. And we also spoke a little bit about this idea of digital resources. This is one other thing that you spend quite a lot of intellectual effort and time on helping people develop some of this language themselves. And we've used ourselves in some of our own reports when we talk to policymakers or people who don't build data centers themselves, because a lot of the time people don't necessarily know how a data center relates to software and how that relates to maybe them using a smartphone. Maybe you could talk a little bit about what a digital resource is in this context and why it's even useful to have this language.
Yeah, and let me try to also connect it to the conversation about the ED. I think when, as a developer, you hear transparency and, okay, they have to report data, what you're thinking is, oh, they're going to have an API where I can pull this information also, let's say, from the inside of the data center. Now, in Germany, it's also funny for everybody listening. One way to fulfill that, because the law was not specific, data centers now are hanging a piece of paper, I'm not kidding, on their fence with this information, right? So this is like them reporting this. And of course, I'm also a software engineer, so we as technical people, what we need is the data center to have an API that basically assigns the environmental impact of the entire data center to something. And that something has always bothered me that we say, oh, it's the server, or it's the rack or the cluster. But ultimately, what does software consume? Software consumes basically three things. We call it compute, network, and storage. But in more philosophical terms, it's the ability to store, process, and transfer data. And that is the resource that software consumes. A software does not consume a data center or a server. It consumes these three things. And a server makes those things, turns actually energy and a lot of raw materials into digital resources. And then the data center in turn provides the shell in which the server can do that function, right? It's the factory building is the data center. The machine that makes the t-shirts is the server, and the t-shirt is what people wear, right?
Ah, I see. Okay. So that actually helps when I think about, say, cloud computing. Like when I'm purchasing cloud computing, right? I'm paying for compute. I'm not really that bothered about whether it's an Intel server or something like that. And to a degree, a lot of that is abstracted away from me anyway. So, and there's good sides to that and downsides to that. But essentially, that seems to be that idea of kind of like cloudy compute and there being maybe, for want of a better term, primitives that you build services with. That's essentially some of the language that you've been repurposing for people who aren't cloud engineers, essentially, to understand how modern software gets built these days, right?
And I think that's also the real innovation of cloud, right? I got to give them credit for that. They disaggregated these things. So when AWS was first launched, it was S3 for storage, EC2 for compute, and VPC for networks, right? So they basically said, like, whatever you need, we will give it to you at scale in infinite pools of however much you need and want. And you pay only by the hour, which before you had to rent a server. The server always came with everything. It came with network, it came with storage, and you had to build the disaggregation yourself. But as a developer, fundamentally, all you want, sometimes you just want compute. Now we have LLMs. I definitely just want compute. Then you realize, I also need a lot of storage to train an LLM. Then you want some more storage. And then you're like, okay, well, I need a massive network inside that. And you can buy each of these pieces by themselves because of cloud. That is really what it is about.
I see. Okay. And this is why I thought it can be a bit difficult when you're trying to work out the environmental footprint of something, because if we're trying to measure, say, a server, but the resources are actually cloud and there's all these different ways you can provide that cloud, then obviously it's going to be complicated when you try to measure this stuff.
Yeah, think about a gigabyte of storage on S3. There may be hundreds of servers behind it providing redundancy, providing the control layer, doing monitoring, right? Like in a way, that gigabyte of storage is not like a disk inside a server somewhere. It is a system that enables that gigabyte. And thinking on that, like trying to say the gigabyte needs to come from somewhere is the much more interesting conversation than to go from the server up. Right? It's misleading otherwise.
All right. Okay. So I'm going to try and use an analogy from, say, the energy sector, just to kind of help me understand this, because I think there's quite a few key ideas inside this. So in the same way that I'm buying maybe units of electricity, like kilowatt hours, I'm buying that. I'm not really buying like an entire power station or even a small generator when I'm paying for something. There's all these different ways I can provide it. But really I care about is the resources. And this is the kind of key thing that you've been speaking to policymakers or people who are trying to understand how they should be thinking about data centers and what they're good for and what they're bad for, right?
Yes.
Okay. All right. Cool. So you're in Berlin and it's surprisingly sunny today, which is really nice. We've made it through the kind of depressing German winter. And I've actually, we've crossed paths quite a few times in the last few weeks because you've been bouncing between, well, you live in Haarlem, Netherlands, and Brussels and Berlin quite a lot. And I like trains, and I imagine you like trains, but that's not the only reason you're zipping around here. Are there any projects related to digital sustainability that you could talk about that have been taking up your time, or like that you're allowed to talk about these days?
Yeah, there's a lot, too many actually, which is a bit overwhelming. We are doing a lot of work still on software, also related to AI. I don't think it's so interesting to go into that. I think everybody on this podcast knows that there's an environmental impact. We now have a lot of tools to measure it. So my work is really focused on how do I get policymakers to act. And one project that I just recently came out, and now that the elections are over in Germany, we can also talk about it, is we basically wrote a 200-page monster called the German Datacenter, not a strategy yet, it's an assessment. And there's a lot of like how much power they're going to use. That's not from us. But what we, for the first time, were able to do is to really explain the layers. So there's a lot of misconception that, say, building a data center creates jobs. But I think everybody in software knows, like, and I think actually all of you should be more offended when data centers claim that they are creating jobs, because it is always software that runs there that is actually creating the benefit, right? A data center building is just an empty building. And what we've been able to explain is to really say, okay, I build a data center, then there is somebody bringing servers, running IT infrastructure, maybe a hoster. That hoster in turn provides services to, let's say, an agency. That agency creates a website. And that's a really complex system of actors that each add value. And what we've shown is that a data center per megawatt depending on who's building it, can be 3 to 6 jobs. And a megawatt is already a very large data center, can be 10,000 servers. And if you compare that to the people on top, like if you go to that agency, that can go to up to 300 to 600 jobs per megawatt. And the value creation is really in the software and not anywhere else. And we believe that the German government and also a lot of regions, and this applies to any region around the world, should really think like, okay, I will build this data center, but how do I create that ecosystem around it that, in Amsterdam is always a good example. You have Adyen, you have Booking.com, you have really big tech companies, and you were like, I'm sure they're using a Dutch data center. Of course not. They're running on AWS in Ireland. So you don't get the ecosystem benefit, but your policymakers think they do, but you don't connect the dots, so to say.
Okay. So if I understand this, so essentially the federal German government, third largest economy, I think it's third or fourth largest economy in the world.
Yes.
They need to figure out what to do with the fact there's lots and lots of demand for digital infrastructure. And they're not quite sure what to do with it. And they also know they have like binding climate goals. So they're trying to work out how to square this circle. And there is also, most countries right now do want to have some notion of like being able to kind of economically grow. So they're trying to understand, okay, what role do these play? And a lot of the time, there has been a bit of a misunderstanding between what the data center provides and where the jobs actually come from. And so you've essentially done for the first time some of this real, actually quite rigorous and open research into, okay, how do jobs and how is economic opportunity created when you do this? And what happens if you have the data center in one place, but the agencies or the startups in another place, for example? Because there seems to be this idea that if you just have a data center, you automatically get all the startups and all the jobs and everything in the same place. And that sounds like that might not always be the case without deliberate decisions, right?
Yes. Without really designing it that way. And it becomes even more obvious when you look at hyperscale and cloud providers, where you see these massive companies with massive profits. And let's say they go to a region, they come to Berlin and they tell Berlin this, having actually Amazon in Spain also sent a really big press release like, we're going to add 3% to your GDP. We're going to create millions of jobs. And of course, every software engineer knows like just building a data center for a cloud provider does not do that. And what they are also trying to distract, which we've shown in the report by going through their financial records, is that they pay property tax. So they pay local tax. In Germany is very low, but they of course don't pay any corporate income tax in these regions. So the region thinks, oh, I'm going to get 10% of the revenue that a company like Microsoft makes. That's not true. And in return, the company asks for energy infrastructure, which is socialized cost, meaning taxpayers pay for this. They ask for land, it's not always available or scarce. And then they don't really give much back. And that's really, I'm not saying we shouldn't build data centers but you have to be really mindful that you need the job creation, the tax creation is something that comes from above, this like on top of a data center.
Higher up the stack.
Yes. And you need to be deliberate in bringing that all together. Like everything else is just an illusion in that sense.
Oh, I see. Okay. So this helps me understand why you place so much emphasis on helping people understand this whole stack of resources being created and where some of the value might actually be. Because it's a little bit like if let's imagine like, say, you're looking at, say, generating power, for example, and you're opening a power station. Creating a power station by itself isn't necessarily the thing that generates the wealth of it, or it's maybe people being able to use it and some of the higher services further up the stack, as it were.
Correct.
And that's the kind of framing that you helping people understand so they can have a more sophisticated way of thinking about the role that data centers play when they advance their economies, for example.
I love that you're using the energy analogy because everybody will hear that, or who's hearing this on the podcast, will probably be like, oh yeah, that's obvious, right? But for digital, to a lot of people, it's not so obvious. They think that the power station is the thing, but actually it's the chemical industry next to it that should actually that's where the value is created, right?
I see. Okay. All right. That's actually quite helpful. So one of the pieces of work you did was actually providing new ways to think about how digital infrastructure ends up being like, how it's useful for maybe a country, for example. But one thing that I think you spoke about for some of this report was actually the role that software can actually play in like blunting some of the kind of expected growth in demand for electricity and things like that. And obviously that has kind of climate implications, for example. Can we talk a little bit about the role that designing software in a more thoughtful way actually can blunt some of this expected growth so we can actually hit some of the goals that we had? Because this is something that I know that you spend a fair amount of time thinking about and writing about as well.
Yeah. I think it's really difficult. The measurement piece is key. Right? Having transparency and understanding always helps. What gets measured gets fixed. It's very simple. But the step that comes after that, I think we're currently jumping the gun on that because we haven't measured a lot of stuff. We don't have a public database of, say, this SAP system, this Zoom call is using this much. We have very little data to work with. And we're immediately jumping to solutions that like, oh, but if we shift the workloads, but if we're, for example, workload shifting on cloud, unless the server is turned off, the impact is zero. Or not zero, it's extreme, but it's very limited because the cloud provider then has an incentive to fill it with some other workload. We've talked about this before. If everybody sells oil stocks because they're protesting against oil companies, it just means somebody else is going to buy the oil stock, and it ultimately brings then spot prices down, but that's a different conversation. So I think let's not jump to that. Let's first get measurement really right. And then it raises to me the question, what's the incentive for big software vendors or companies using software to actually measure and then also publish the results? Because let's be honest, without public data, we can't do scientific research. And even communities like the Green Software Foundation will have a hard time, making a report or making good analysis if we don't have publicly available data on certain software applications.
I see. Okay, this does actually ring some bells because I remember when I was involved in some of the early things related to working out, say, software carbon intensity scores, we found that it's actually very, very difficult to just get the energy numbers from a lot of services simply because that's not the thing because a lot of the time, if you're a company, you might not want to share this because you might consider that as commercially sensitive information. There's a whole separate project called the Real-Time Cloud project within the Green Software Foundation where the idea is and there's been some progress putting out, say, region by region figures for the carbon intensity of different places you might run clouding, for example. And this is actually like a step forward, but at best, we're finding that we could get maybe the figures for the carbon intensity of the energy that's there, but we don't actually have access to how much power is being used by a particular instance, for example. We're still struggling with this stuff. And this is one thing that we keep bumping up against. So I can see where you're coming from there. So, all right. So this is one thing you've been spending a bit of time thinking through, like, where do we go from here then?
Yeah, I think first we need to give ourselves a clap on the back because if you look at the amount of tools that can now do measurement, like commercial tools, open source tools, I think it's amazing, right? It's all there. Dashboards, Prometheus things, REPL interfaces, it's all there. Now, the next step, and I think that's as software people, we like to skip that step because we think, well, everybody's now going to do it. Well, it's not the reality. Now it's about incentives. And I think, for example, one organization we work with is called CFIT. It's a conglomerate of government purchasers, IT purchasers, who say, okay, we want to purchase sustainable software. And to me, it's very difficult to say, and I think you have the same experience. Here are the 400 things you should put in your contracts to make the software more sustainable. Instead, what we recommend is to simply say, well, please send me an annual report of all the environmental impacts created from my usage of your software. And very important phrase we always put in is, and please also publish it.
Yeah.
Again. And I think right now, that's what we need to focus on. We need to focus on creating that incentive for somebody who's buying even like Google Workplace or like Notion to really say, hey, by the way, before I buy this, I want to see the report, right? I want to see the report from my workplace. And even for all the people listening to this, any service you use, like any API you use commercially, send them just an email and say, hey, I'm buying a product, I'm paying 50 euros a month or 500 or 5,000 euros a month. Can I please get that report? Would you mind?
Yeah.
And that creates a whole chain reaction of everybody in the company thinking, oh my God, all our customers are asking for this. We need this. One of our largest accounts wants this. Figure it out. And then they go to the Green Software Foundation or go to all the open source tools. They learn about it. They implement the measurement. Then they realize, oh, our cloud providers are not giving us data. So then they're sending a letter to all the cloud providers saying, like, guys,
can you please
have
provide
this,
us these
right?
numbers? Yeah.
Yes. And this is the chain reaction that requires all of us to focus and act now to trigger.
Okay, so that sounds like, okay, when I first met you, you were looking at, say, how do you quantify this and how do you build some of these measurement tools? And I know that there was a German project called, was it Soft Aware, which was the German take on Soft Aware that does try to figure these out, to like come up with some meaningful numbers. Now, the thing it looks like you're spending some time thinking about is, okay, how do you get organizations with enough clout to essentially write in the level of disclosure that's needed for us to actually know if we're making progress or not, right?
Yes, correct. The little side anecdote on software, the report is also a 200-page piece. It's been finished for a year and it's not published yet because it's still in review. So it's a bit to pain. But fundamentally, what we concluded is that, and there's other people that have already, while we were writing it, built better tools than we have. And again, research-wise, this topic is, I don't want to say solved, but all the knowledge is out there and it's totally possible. And that's also what we basically said the report, like, if you can attach to the digital resource, if I can attach to that gigabyte of S3 storage that is highly redundant or less redundant, an environmental product declaration. So how much physical resources went in it, how much energy went into it, how much water, then any developer building a software application can basically then do that calculation themselves. If I use 400 gigabytes of storage, it's just 400x what I got environmental product report for. And that information is still not there, but it's not there because we can't measure it. It's there because people don't want to, like you said, they don't want to have that in public.
Okay. So that's quite an interesting insight that you shared there, is that because when we first started looking at, I don't know, building digital services, there was a whole thing about saying, well, if my web page is twice the size, it must have twice the carbon footprint. And there's been a whole debate saying, well, actually, no, we shouldn't think about that. It doesn't scale that way. And it sounds like you're suggesting, yes, you can go down that route where you directly measure every single thing. But in aggregate, if you want to take a zoom out, if you want to zoom out to actually achieve some systemic level change, the thing you might actually need is kind of lower level per primitive kind of allocation of environmental footprint, and just say, well, if I know that the thing I'm purchasing and building with is, say, gigabytes of storage, maybe I should just be thinking about in terms of each gigabyte of storage has this much, so therefore I should just reduce that number rather than worrying too much about if I halve the numbers, it's not going to be precisely a halving in emissions because you're looking at a kind of wider systemic level.
First of all, I never talk about emissions because that's already like a proxy again. Mm-hmm. I think if you take the example of the browser, what you just said, I think there it becomes really obvious. What you really want is HP, Apple, Dell, any laptop they sell, they say, there's 32 gigs of memory per gigabyte of memory. This is the environmental impact. Per CPU cycle, this is the environmental impact. How easy would it be then to say, well, this browser is using 30% CPU, half of the memory, and then again, assigning it to each tab. It becomes literally just a division and forwarding game mathematically, but it's the scarcity that the vendors don't ultimately release it on that level makes it incredibly painful for anyone to
kind of reverse engineer and work backwards.
You get it for the server, for the whole thing, but that server also, which configuration was it? How much memory did it have? And this subdivision, that needs to happen. But again, that's a feature that I think we need to see in the measurement game. But I would say, again, slap on the back for all of us and everybody listening. The measurement is good enough, right? For AI, we really see it. Like, I think for the first time, it is at a scale that everybody's like, it doesn't really matter if we get it 40 or 60% right. It's pretty bad, right? And instead of now saying like, oh, let's immediately move to optimizing the models, let's first create an incentive that we get all the model makers, and then especially the service providers and the APIs, to just give everybody these reports so that we have facts. And that's really important to make policy, but also then to have an incentive to get better.
Okay, so like have a data-informed discussion, essentially. All right, so you need data for a data-informed discussion, basically.
Yes,
all right.
To add to that, it's really because you like analogies and I like analogies. It's a market that is liquid with information. What I mean by that, If I want to buy a stock of a company, I download their 400-page financial report, and it gives me a lot of information about how good that company is doing. Now, for software, what is the liquidity of information in the market? It's for environmental impact, it's 0. The only liquidity we have is features. There's so many videos for every product on how many features and how to use them. So we have even the financial records of most software companies you can't actually get because they're private. So we have very scarcity of information, and therefore competition in software is all about features, not about environmental impact. And I'm trying to create information liquidity in the market so that you and I and anybody buying software can make better choices.
Okay. And this helps me understand why, I guess you pointed to, there was that French open example of something equivalent to like word processing. I think there should be this French equivalent to like Google Docs, which is literally called Docs. Yeah. And their entire thing was it looks very similar to the kind of tool you might use for like note taking and everything like that. But because it's on an entirely open stack, it is possible to like see what's happening inside it and understand that, okay, well, this is how the impacts scale based on my usage here, for example.
But now one of our friends, Arne from Green Coding, would say, yeah, you can just run it through my tool and then you see it. But I want that it's still just research information. We need liquidity on the information of, okay, the Ministry of Foreign Affairs in France is using Docs. It has 4,000 documents and 3,000 active daily users. Now that's where I want the environmental impact data, right? I don't want a lab report. I don't want to scale it in a lab. I want the real usage data.
Okay, so that feels like some of the next direction we might be moving to is almost looking at some of these things, seeing like sacrificing some of the precision for maybe higher frequency information of things in production, essentially. So you can start getting a better idea about, okay, when this is in production or deployed for an entire department, for example, how will the changes I make there scale across, rather than just making an assumption based on a single system that might not be quite as accurate as the changes I'm seeing in the real world.
And you and I have two different bets on this that go in a different direction. Your bet was very much on sustainability reporting requirements, both CSRD or even financial disclosures. And my bet is if purchasers ask for it, then it will become public. And those are complementary, but they're bets on the same exact thing: information liquidity on environmental impact information.
Okay, all right. Well, Max, this has been quite fun, actually. I've got to ask, just before we wrap up now, if people are curious and have found some of the stuff you're talking about interesting, where should people be looking if they'd like to learn more? Like, is there a website you'd point people to, or should they just look up Max Schulze on LinkedIn, for example?
That's always a good idea. If you want angry white men raging about stuff, that's LinkedIn. So you can follow me there. The SDIA is now focused on really helping regional governments developing digital ecosystems. So if you're interested in that, go there. If you're interested more in the macro policy work, especially around software, we have launched a new brand. That's our think tank now, which is called Leitmotiv. And I'm sure we're going to include the link somewhere in the notes.
Natürlich.
Yeah. Very nice. And yeah, I urge you to check that out. We're completely independently funded now, no companies behind us. So a lot of what you read is like the brutal truth and not some kind of washed lobbying positions. So maybe you enjoy reading it.
Okay then, all right. So we've got Leitmotiv and we've got the SDIA and then just Max Schulze on LinkedIn. These are the three places to be looking for this sort.
Yeah.
All right. Max, it's lovely chatting to you in person. And I hope you have a lovely weekend and enjoy some of this sunshine now that we've made it through the Berlin winter. Thanks, Max.
Thanks, Chris.
Hey everyone, thanks for listening. Just a reminder to follow Environment Variables on Apple Podcasts, Spotify, or wherever you get your podcasts. And please do leave a rating and review if you like what we're doing. It helps other people discover the show. And of course, we'd love to have more listeners. To find out more about the Green Software Foundation, please visit greensoftware.foundation. That's greensoftware.foundation in any browser. Thanks again and see you in the next episode.